What's going on, guys? Today we're going to be talking about the iterator pattern. So let's talk about it. So this design pattern is actually pretty frequently used. I'm pretty sure you've used it or seen it before. And the Gang of Four defines it as provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. Now, the underlying representation means stacks, lists, trees, arrays. It doesn't really matter. Any kind of collection or data structure. That's what it means with underlying representation. And now for the overall summary, it basically means that you could traverse elements of a collection, meaning go forward, backwards, up and down a list, freely, I guess. You can move it around without, you know what I mean. So let's go into the code, and I'm gonna show you a pretty simple code. So I have an inventory list item or class, inventory item class, which basically has a name and a price, and it's going to give us a standard output of the name and the price. I mean, this is a pretty simple class. The index is where it gets pretty interesting. Now, if I run this right now, nope. If I run it, if I press up, it's gonna tell me up. If I press right, tell me right, left, down, you know. So it's actually overriding what you see on the terminal. It's not a console log, it's actually a standard output, which completely takes over of what you had in the console. So I'm not gonna I mean, you can look at this code and pretty much figure it out. So I'm not gonna go over what I wrote here, but the point is, in here, this is where we're gonna create our iterator. So let me just get out of this, and right here, instead of writing out the right or the actual direction we're pressing the keys, we're gonna actually go into it. And we all know how to iterate through an array and whatnot, and you can actually do this. You could actually probably code out, if you press right, get the next element of the array here. If you press left, get the previous element from that array. But the thing is, the iterator is meant to be used for different collections. It has an interface that would do it for different collections. You know what I'm talking about? So if I did decide to do it with the array right here, getting the array to the right, well, let's say that you want to get it the right or the next element of a tree. Well, writing an array code is not going to be the same as writing for the tree, right? So this is why we have an interface. So in here, instead of writing out the right, we're going to actually go to the inventory, which is up here, our array of stuff. And we're just going to, right now it's an array, right? But I'm going to say a collection. This could have been a tree, it could have been a stack, it could have been all sorts of things, but I just decided array for simplicity. So we're going to do inventory dot next. We're going to call next, and we're going to do and call out the method that we have in here, which is write line. Okay, write line, just like that. And we're gonna actually grab this line, and we're gonna do it for here as well. I'm gonna do it right here as well, and right here. Oops. Home. Okay. And paste. Now we're gonna do it for the right. We're grabbing the next. For the left, we're gonna grab the prev. Okay. What am I doing here? Eve. Okay. And right here, we're gonna get last. And when we do the up key, we're gonna get the first element of the array. So this is pretty much simple stuff, guys. Control save. Now we're gonna go into our inventory item right here and actually start adding all the methods that we added here, which is the next, prev, last, and first. Scratch that. We're not going to be doing it in the inventory item. We're going to be doing it in a different file. So up here, we're going to create a new file. Require dude, where's my comment? There it is. Okay, we're gonna call it the iterator I'm sorry guys, I was looking at my notes and I was like, yep, I need my I forgot this one thing up here. And actually in here, instead of just assigning this inventory an array, we're gonna assign inventory a new instance of this iterator and passing in the array or the collection inside the iterator. So new iterator, and we're gonna just pass it in the array. That's it. And then now we could actually create another file called the iterator. So new file, iterator.js, and in here this is where we're gonna actually do our iterator. So let's do a class, call it iterator, and we're gonna export this. So module dot exports is going to equal iterator. And then inside of here, we're gonna get all of those methods, right? So we're gonna have our next, our prev, our last, and our first. Now, with these iterators, you typically have a has next kind of method. So has next, and then you also have the current, right? Although we don't call these, but you typically do have it because you do want to know what you're currently on, or if it does have a next. So we're gonna go start with the constructor, and the constructor does take an array, so I'm gonna just call it items. And if we don't pass in something, I'm just gonna pass in, I'm gonna default it to an empty array. And then we're gonna say this dot index, we're gonna set that to 0 because we want to start off with 0 for our first index. And then this dot items is going to equal items. Okay. Now let's start with our first of all. Down here, obviously we're going to return. We could do it a simple way. I'm pretty sure you know that you could do it this dot items, and then return the first item or element in the arrays list, right? But JavaScript actually gives us a pretty cool way of doing this, and we're gonna actually assign it var. We're gonna destructure the first item first, just like that, and it's going to pass in this dot items, and this will give us the first element inside the array, which is pretty cool. Obviously, if you wanted the second one, you could have done like second, like this, but we just want the first one, and we're gonna just return first. It's pretty cool. I'm just laughing because if you look at this for a very long time, you start thinking, well, this is how I think. I'm not too sure if everybody does this, but you start thinking that this is it starts looking weird, the words. I'm not too sure. Anyways, we could do the same thing with last. So we can actually destructure this. So we can actually copy this right here, right? But instead of getting the first one like this, we're gonna actually have to reverse the array. So dot, I'm gonna just do this so that way we make a copy. It's not a good idea to actually manipulate the original array. We want to make a copy of the array. So I'm actually set this in brackets and use a spread operator to copy this dot items. And then we're gonna reverse the array so that way now it's reversed, and we're gonna grab the last. It's gonna be called the last item and last. Control save, which is pretty cool. It just gives you a new way of actually doing things. You know, so you're welcome. Going on to current, the current is going to be pretty simple. Return this dot items and this dot index. Whatever index we're in, we're gonna return that. So if we're on 0, it's gonna return the first one. Obviously, whatever index we're in, we're gonna return that. Let's go to has next. All right, for has next, we're gonna return this dot index if it's less than this dot items dot length -1 -1 I mean, just like that. So this is gonna not like that, like this. So this is gonna return if it does actually has a next. So if it doesn't equal a -1, which means it's reached the end of the array, then we're okay. Now going to the prev, or we could actually do next. Now for the next, we do have to check if this dot has next. That's why we have the has next method right here. Or this is one of the reasons why you would want to use has next. We're gonna check that. If it does, then great. We're gonna do this dot index plus equals 1. We're gonna just add a 1 to that index, and then we're gonna return this dot current, and I spelled current wrong. And you'll see, like, remember, current is going to return this, whatever the index is, which we just incremented here, and this is why we're calling current. Now going to the prev, we do have to check again. So if this dot index does not equal 0, if it does equal 0, obviously you're in the first element in the array. So we're gonna do this dot index, and we're gonna just decrement it by 1. Minus equals 1, just like that, and we're gonna return this dot current again. And I didn't do the return statement in front, so return this dot current. Control save. So this is our iterator class, which I mean, you know, it's pretty simple stuff, guys. But this is how you would do it. You would, if you had another data structure, you would include it in here. You know, you'd probably use the type of. If it's an array, then do it this way. If it's a tree, then do it this way. You know, but it's pretty simple. I'm like, guys, I'm telling you, this is a pretty simple one. Now, if we actually run this again, oh, I forgot to do something. I'm so sorry. Control C out of that. Sorry, guys. I was debugging and I did forget. It's always something so simple. I forgot to add the parentheses be on the end of this. That's why you didn't see anything when we originally tried it. And let me just add the closing, opening and closing in parentheses on all of these. Control save this. Now, if we try it, press any key. So if you go to the right, we should get the next, which you can see right here. We're grabbing the next. So mouse pad. If I go up, we get mouse, which is our first item. If I go down, we get memory, which is yes. If I go to the left, we should get mouse pad. It's going to be the last, whatever we had last. Keyboard, monitor, mic, desktop, laptop, memory. And we can't go to the right no more, so let's go back. Laptop, desktop, mic, down, up, down, up. It's pretty cool. But yeah, that's the iterator pattern, guys. So let's go straight to the pros and cons and when and where you would use this. So let me actually provide you a quick summary of what an iterator is supposed to do. So it's supposed to provide a uniform interface to actually iterate through any collection available. All right, so that's basically what it is. A simple interface that you could just dump into any collection, dump that into the interface, and it'll iterate through everything. That's basically what it is, guys. So let's go for the pros and cons. The pros and cons. You can clean up the client code and the collections by extracting bulky transversal algorithms into separate classes. You can implement new types of collections and iterators and pass them to existing code without breaking anything. You can iterate over the same collection in parallel because each iterator object contains its own iterator state. like we've done, like in the code, we did have that new iterator. We're creating an instance of that iterator. You can create multiple instances, and every instance is going to have their own index. Yeah, so you can loop through multiple collections if you wanted to in the same application, and it'll iterate the way as expected. And for that same reason, you can delay an iteration and continue it when needed, which is a pretty cool thing. So for the cons, applying the pattern can be an overkill if your app only works with simple collections, obviously. I thought that I needed to add that in because, you will, I guess, just by learning something new, you want to incorporate it. But if it's a simple application, don't do it. Using an iterator may be less efficient than going through elements of some specialized collections directly. So that's another con. All right, let's go to the wins. So the wins. Use the iterator pattern when your collection has a complex data structure under the hood, but you want to hide its complexity from clients. So either for convenience or for security reasons. So a little bit about this. The iterator encapsulates the details of working with a complex data structure, providing the client with several simple methods of accessing the collection elements. While this approach is very convenient for the client, it also protects the collection from careless or malicious actions, which the client would be able to perform if working with the collection directly. So that's why we said for either convenience or security reasons. Use a pattern to reduce duplication of the transversal code across your app. So the code of a non-trivial iteration algorithm tends to be a very bulky one. So when it's placed within the business logic of an app, it may blur the responsibility of the original code and make it less maintainable. So by moving the transversal code to a designated iterator, it can help you make the code of an application more lean and clean. Lean and clean. I didn't even try it. That's pretty, yeah. Okay. And last but not least, use the iterator when you want your code to be able to transverse different data structures or when types of these structures are unknown beforehand. So the pattern provides a couple of generic interfaces for both collections and iterators. Given that your code now uses this interface or these interfaces, it'll still work if you pass it various kinds of collections and iterators that implement these interfaces. So that is it for this, guys, for this video. Anyways, if you haven't, please subscribe. Leave a comment down below on your thoughts about the video and where would you use this design pattern, and also leave a like if you liked it or a dislike. It's up to you. But thanks, guys, and as always, thanks for taking time out of your day to watch these videos. And I know you're probably a busy guy or gal, and I do appreciate you watching my videos. And I do hope you learned something from these. So thank you so much, guys, and I will see you in the next one.